All right, so we're going to take a look at function type and writing equations from a table. We've done this previously, so this is going to be just a quick review. Accountancy has this following table. How do I prove that it's quadratic? All right, in order for you to prove that it's quadratic, you need to know that the second difference is constant. All right, so in order to check that it's quadratic, we also have to check that it's linear. And I'm also going to review how to check if it's exponential. So I'll start with exponential. So exponential says that the ratios, what I'm multiplying each time, is constant. All right, what does that mean? When you take your second y value, which is negative 46, divided by your first y value, which is negative 7, all right, you get a ratio. So this is called a ratio when you have a number over a number. So it's 6.571. If I'm multiplying by 6.571 every time to get the next one, then those ratios are constant. All right, so instead of me multiplying by this decimal, I'm just going to check the next two numbers. So negative 163 divided by the previous one, which is negative 46, divided by. All right, the ratio is not the same. So these ratios are not constant. So it is not exponential. All right, I'm going to check linear. So for linear, it's not the ratios that is constant, but the common difference is constant. What that means is the difference between these two numbers is going to be the same every single time. So let's check that. All right, so we have this. So you start with y2 just as before. So negative 46. But instead of checking the ratio, which is divide, right, it's subtract, because this one is called difference. So this is called the first difference. All right, because it's the word difference, I'm looking for the difference between them. So negative 7. So this first difference is negative 39. And what that means is if negative 7 minus 39 is going to give me this one. All right, so now we're going to check, is that first difference going to keep being constant? In other words, negative 39. Well, let's check the other number. So we have negative 163, and then subtract, because it's difference, of negative 46. And now I'm getting the difference between these two numbers is 117. So you can see that the first difference, the first time I do this, they are not consistent. All right, let me check the other number. Now, if I was looking for linear, I would stop here. But because I'm looking for quadratic, I'm going to keep going until I have a few numbers, and I'll show you why in just a second. So the difference between these two numbers is 195, negative 195. And the difference between this one without putting in the calculator is negative 273. That's the first difference. The first time I look at the differences. Now, it says here to prove it's quadratic, the second difference is constant. What that means is the second time I do this, I find the difference between the numbers. So the difference between these two numbers, the difference between these two numbers, the difference between these two numbers. If those are constant, then it's quadratic. So let's do that. So my second one is negative 117 minus, because it's difference, negative 39. All right, negative 78. So what we're saying is if I get negative 78 is the difference between these two, and the difference between these two is also negative 78, then it is quadratic. So negative 195 minus negative 117. And that is indeed negative 78. So this is looking like it could be quadratic. Let me check the last one, negative 273 minus negative 195, and boom. Because the second difference, again, not the first difference, the second difference is constant, it is quadratic. So first difference would be linear. Second difference would be quadratic. All right, now I've just reviewed how you check from a table which is which. Now I'm also going to talk to you, that's by hand. I'm also going to talk to you how to do it with a calculator, and your preference is fine with me. I don't mind whichever method you want to do. All right, so what I'm going to do is, it says in the Desmos calculator, click the top left corner, so plus. Then table, boom. Input your x and y values. So here are my x and y values. So it goes 0, 1, 2, 3, 4, and I'll put the 10 in later because I don't know what that one is yet. And then here it's negative 7. And the only thing I can say about this, guys, is just be really careful to double check your numbers to make sure that you typed in the right, the correct thing. All right, so input your numbers, your x and y values. You can see it's labeled x1 and y1. All right, type the equation for the function you want. So right now, I don't know what this function is. So now I'm going to show you how to do this with a calculator and make this a little bit bigger. Instead of zooming out traditionally, right at the bottom left of your table, there's this plus sign right here. It zoom fits the points. So if you click on it, look at what it did. It fitted the points. Now this could be, now be careful with just going off of this, because this could be exponential flipped, or it could be half the quadratic. So for me, I would know if I put the table in and it's a curved line, I'm definitely not checking if it's linear. I'm checking quadratic and exponential. So what I do is you're going to type the equation for the function you want. Okay, there are 3 functions. You should have this in your notes, but also you have it in your formula sheet. So if you think it's linear, you should be typing y equals mx plus b. If you think it is exponential, you should be typing y equals ab to the power of x. And if it's quadratic, you should be doing the standard form, y equals ax squared plus bx plus c. Because I think it's quadratic, that is the one that I'm going to type in. So I'm going to type in ax squared plus bx plus c. And it says here, there is an error, right? Because there's an error right there. All right, what are the 2 things you need to change? We've done this previously, but we're going to cover this again. There are 2 things I need to change in order for the calculator to get it. For one, for whatever reason, it does not like this equal sign. So we're going to write the equal sign needs to change to tilde or squiggly line. So you come right here, delete the equal sign, go right here, press ABC, tilde or shift, and right underneath the escape key. All right, now, it still doesn't like something. And that is because this is what you're telling the calculator. Hey, calculator, give me the equation. The calculator is like, the equation of what? Well, I want the equation of this table. Okay, cool. But what did you label? Did you label x1, y1? No. So the calculator doesn't know to go up here and get it. So you have to tell it, hey, calculator, I want you to use this as your y1 value. So you come to where y is and type in 1. And everywhere I see x, I'm going to type in that x1 value. So everywhere I see an x, 1. x1. Oops, not 2. And as soon as you do that, it should go perfectly over all of your lines, okay? So again, zoom fit to make sure it goes over your lines, because sometimes it's very, very close. Therefore, this is definitely quadratic because it's giving me a quadratic. Oh, Miss Ainley, well, what is my equation? Well, we know it's y equals ax squared plus bx plus c, right? Okay, so how do I write that? A is negative 39. So this is going to be y equals negative 39 x squared, all right, ax squared plus bx, so b is 0, so plus 0x, all right, plus c, which is what? Negative 7. So instead of me putting plus, I'm actually just going to put negative 7. And we can simplify this because 0x is nothing, so this can be y equals negative 39x squared minus 7, because that 0x is nothing. All right, and that's how you're using the Desmos calculator. All right, so if it's a linear function, you're doing y1 or y2 or y3 or whatever the table says, squiggly line, mx1 or x2 or x3 or whatever this table says, plus b. If it's quadratic, you're using y1 or y2, y3, y4, whatever it says, squiggly line, ax1 squared plus bx1 plus c. And if it's exponential, you're saying y1 or y2, y3, or y4. This is a parentheses b to the power of x1. Okay. All right. The 2 things you need to change is the equal sign to squiggly line, and then x and y to x1 and y1. All right, so now what you're going to do is, now that I've reviewed all of it, how to put it in the calculator, how to do it by hand, you're going to look at 1, 2, 3, 4 tables. You're going to tell me what kind of function is it. So is it linear, quadratic, exponential, or neither? You're also going to evaluate the function at a different number. So let me show you how to do that. So right now I have this, and I want to evaluate it at 10. 2 ways I can do that. I can go to 10 on my graph. So I'm just going to zoom out real quick and get to 10. There's 10. Go down to where I hit the graph. Zoom in so I can see the number. Keep in mind, you see, I still see the 10 right here. Zoom in, zoom in, zoom in. See the 10's right there. So it looks like 10 is right there. All right, negative 3,907. Negative 3,907. So you can do it with the graph, or you can type this into the calculator. Get rid of the ones, because again, the ones is just for the calculator. So equals, and the x1s, boom. Put in the actual numbers. All right, so the number for A is negative 39. I'm just being lazy to not copy it down. 0, and this is negative 7. Make it a table, so boom, table. And then go to 10 or type in 10, and you can see you get the same exact number. So you can look at the graph, you can put it into the equation, make it a table, you can replace all the x's with 10, it'll get you the same answer. So for each of these questions, that's what you're doing. What is it? Find the 10th value or a different value if it has the 11, 12, and 4. This function is what? Linear, exponential, quadratic, neither. Why? And then what is the equation? So for each one, let's practice.